In our last video, section 3.1, we discussed solving systems of equations graphically. We literally just graphed out the lines and decided where they intersected, and we decided that would be our solution, where x and y are the same for both of our equations. In this section, 3.2, we will solve systems of equations algebraically. And by that I mean we will manipulate the actual equations to find a spot where x and y are the same in both of our equations. So we won't have to do any graphing at all. Now there's two ways to do this. There's two methods, substitution and elimination. Okay, they're two completely different forms, but essentially in both cases you are solving out the equations without having to graph anything. So in our first one, or looking at our first example, we'll be talking about substitution. It's one algebraic method to solve our systems. In this method, you're literally solving for one variable using one of your equations and substituting it in to the other equation. Okay, so it's getting one variable alone and then just plugging in the rest of that value into the other equation. And I'll show you what I mean here on our first example. So for this one, we are going to use substitution to solve the system of equations. We have x plus 4y equals 26. That's our first equation. We have x minus 5y equals negative 10. That's our second. Now in our second equation, if I were to add 5y to both sides of the equation, I could turn it into x equals 5y minus 10. Okay, in doing so, I've got the variable x all alone, all by itself, and so I can use that and plug this whole piece, 5y minus 10, I can plug that in for x in the other equation. And we'll do so right now. Okay, looking at our other equation, we had x plus 4y equals 26. Well, instead of saying x, I plugged in this 5y minus 10 right into the spot where x was, and then continued the rest of the equation. So it's now 5y minus 10, that amount, added on to 4y equals 26. Now in this case, I don't really need the parentheses anymore because we're not multiplying by anything or subtracting what's inside there. So I can basically get rid of those and now just kind of look at the equation as one big piece, and we can start combining our like terms. So all of our y values, 5y and 4y, and they're both positive, they're all being added together, so that became 9y. Then I can look at all of my constant terms. I just have this minus 10 or a negative 10. So again, that becomes a minus 10, negative 10. And our right side stays as 26. Now, on this equation, all I have to do is add 10 to both sides to get rid of that minus 10. So it becomes 9y equals 36. Probably guessed it. All we're going to do is divide both sides by 9 to get y alone, and we would get y equals 4. So in this case, we figured out in both equations, if I have y equals 4, that's going to be the spot where both equations are the same. We haven't discovered the x value yet, but we know the y value is going to be 4. So if we want to find out what that x value is, we simply take one of our equations and just plug y in. So again, all I did is plug this y equals 4 into one of our equations. And you could use either one. I just happened to use the first one. So instead of saying x plus 4y equals 26, I now have x plus 4 times 4, because I plugged in y equals 4. So x plus 4 times 4 equals 26. Simplifying that 4 times 4, it just becomes the constant 16. So we have our x term alone, x plus 16 equals 26. Probably guessed it, we're going to subtract 16 from both sides. So we would say x equals 10. So we found our two values, our x and our y, that would be the same in each case. It's going to be the spot where both of these lines would go through that exact point. So you can leave your solutions as x equals 10 and y equals 4, or you can call it the solution, call it the coordinate point 10, 4 as your solution, because remember, this is an exact point. It's also probably always a good idea to get in the habit of checking these and making sure they actually check out. So I'm going to move this out of the way, give myself some space to work. Actually, might as well delete these. Oops, there we go. So if I wanted to check 10 and 4, we just plug it into our first equation here. X is 10 plus 4 times 4 equals 26. Well, 4 times 4 is 16, so 10 plus 16 equals 26. And that is in fact true, so our first one checks out. Okay, move those pieces aside. Let's try this second equation. X is 10, we said, minus 5 times 4, y was 4, equals negative 10. Let's make sure that's true. 10 minus, well, 5 times 4 is 20. 10 minus 20 is indeed negative 10. So that one checks out as well. Perfect. So that was our first example. We're solving with substitution.